Okay, thank you. I take the presenter. Thank you for this kind introduction. Thank you. It's great to be here and to give you some insights about the thinking of a mobile network operator. Because what I got so far is an impression that most of the talks are about how many cars are equipped with connectivity, what kind of services can be done with that. And we, from a mobile network operator side, we are pretty sure that connectivity will come in every car. 100% of the cars will be equipped with connectivity. So that is, let's say, for us as a mobile network operator, good news. So I'm responsible for the 5G automotive program inside the Deutsche Telekom group. And Deutsche Telekom is not only managing about the mobile networks, which are behind the connected car, but we are also providing a lot of IT services out of our IT systems division for connected car services. So the big bunch of services which are related to the connected car are coming also from our or via our data centers. So as I have said, connectivity today is a matter of fact. If we take the premium, especially the premium car manufacturers, we can see that nearly 100% of the cars, newly produced cars, are equipped with connectivity. So no doubt about that. It's there. It's used. It's used also for a variety of services without any kind of user subscription, because the car manufacturers had realized that they need connectivity to get continuously into a close contact with their customers. So the customers itself expect that the car is connected. So connectivity between a car and a backend infrastructure, a cloud infrastructure, and of course beyond the cloud, because behind the cloud of the car manufacturer, there are a variety of additional clouds connected. So connectivity is a matter of fact. No doubt about that. It's there, and we have to continuously, from a mobile network operator perspective, we have to continuously invest that this connectivity can be used inside the car. Coverage, quality of service aspects, and so on. I will come back to that later. But not only the car has its connectivity, also the customer has its connectivity, because he don't want to lose connectivity if he goes into the car. And if it comes to autonomous driving, and the customer gets more freedom, gets more time to use his time for other purposes, most likely this customer connectivity, which will be much more important. The connectivity is not only used for a variety of, let's say, old-fashioned traditional telematics purposes. It's also used for a lot of sensoric information, exchange of sensoric information, analytics of sensoric information to extend the sensorical infrastructure of the car itself. So the, let's say, back-end sensor, the shared sensor, the sensor which comes maybe from other cars, from a crowdsourced infrastructure, is a very important data source, especially if it comes to autonomous driving. So if we are looking a little bit more into the future, most likely, whether we are talking about LTE as a radio interface infrastructure, or whether we are talking about a 5G as a radio interface structure, additional services will come and will be much more important. First of all, the cars can communicate with each other. And maybe some of you are aware that we have right now a very important let's say, discussion in the automotive industry, and not only in the automotive industry, but also together with the roadside operators, with road operators, which are operating roadside infrastructure. What is the most appropriate technology for using vehicle-to-vehicle, vehicle-to-infrastructure communication? And we, from a 3GPP community, from a cellular connectivity world, we are providing right now additional functionalities which are able to realize a direct communication mode between cars and between car and traffic infrastructure, like traffic lights, road construction indicators, and so on. So that's a new LTEV, which is now available, also commercially available with chipsets, with modems, and most likely these kind of infrastructure will be incorporated into our networks, as well as into our traffic infrastructure, as well as into the cars. If you are talking about upcoming network capabilities, most likely some of these cloud and above cloud functionalities will migrate from the cloud more into the network infrastructure. And that is meant with this acronym Mobile Edge Computing, MAC. Mobile Edge Computing infrastructure where we as mobile network operators will provide in the future, and we are doing that right now with a variety of test beds, cloud infrastructure, small cloud infrastructure directly in our networks. So what is the most important benefit for the car, for the customer, for traffic safety reasons, for a variety of other participants on the road? That's first of all latency, so we can reduce the latency between different entities below 20 milliseconds. So we achieved already below 10 milliseconds. Of course, the 10 milliseconds are varying a little bit related to the traffic conditions, but most likely we can achieve latency issue below 20 milliseconds for that mobile edge computing infrastructure. And a very important second factor for mobile edge computing is the availability, because the cloud is not somewhere distributed in the world with a lot of network components in between. No, it's directly at the UE, it's directly at the car in a very close distance. Only a very limited number of components are involved in processing time and data transmission. So the availability can be significantly increased with such kind of mobile edge computing infrastructure. Of course, we are using narrowband IoT for a variety of purposes, but also in the future Cat-M. That is especially for connecting a variety of traffic infrastructure via our networks to backend infrastructure, but also to use it inside the car, because there are also some side and niche use cases where the customer needs to have connectivity. So if you would like to take a drive now, for instance, to go back to the airport, most likely you need connectivity to open the car. And if the drive now stands in the third floor of the garage, then coverage might be a problem. So Cat-M is an answer from us as a mobile network operator community to solve these coverage problems, especially in these niche use cases. And because the connected car is only one traffic participant on the road, there are a variety of other traffic participants on the road, like pedestrians, like cyclists, like motorcyclists. We have also the responsibility, especially if it comes to safety, to connect also these customer groups into a traffic-related ecosystem. Whether it's the normal, let's say, mobility as a service concept, or whether it is directly related, safety-related aspects. And finally, as I said, the customer connectivity is very important, and it becomes even more important if it comes to autonomous driving. There's also a very nice aspect where we can leverage our network capabilities, and that is, for instance, positioning. Most likely, every car which is connected uses also a GNSS positioning method to position himself on the road together with other sensoric infrastructure inside the car, like these kind of sensor fusion concept of odometer, tachograph, and so on. And we, as a network operator, can provide additional correction information, like differential GNSS correction information, via our networks to even improve the position accuracy of the car. So again, the network can fulfill a very important task. So I would like to give you some examples what we have already implemented and deploying together with our customers. That is one very good example where customer connectivity and the car connectivity goes hand in hand. So you have, as a customer, you find a wireless hotspot in your car. You can lock your normal services together with that wireless hotspot. The wireless hotspot is realized via a mobile network connection. And this kind of integration and usage enables the customer that he can use his variety of services regardless of some kind of car infrastructure, and especially if it comes to autonomous driving, where the customer has more time to use and to explore these kind of services. This is a very good example of how to integrate customer connectivity together with car connectivity. We are exploring right now here next to door at the A9. So if you go back to the airport, the whole infrastructure around the motorway, which takes you back to the airport, is equipped right now with upcoming 5G technology, mobile technology infrastructure. So we are discussing in a very intensive way right now what kind of algorithms, what kind of analytics has to take place in the car, what kind of algorithms, what kind of analytics has to take place in the cloud, and what kind of analytics can take place in between, in the edge. And as I said, if you put some analytics from the cloud into the edge or from the car into the edge, you can achieve first, of course, you can realize a very good realization of the computing power of the network. Second, you can achieve a very low latency between cars and between car and roadside infrastructure. And third, it's also important that availability can be realized significantly. We are doing that not only by ourselves as Deutsche Telekom, so that is not only a single purpose activity of one network operator. It's also very important to note, and we have seen all these kind of numbers in the various regions of the world. Our customers are selling their cars in more than 150 different countries, 160, 70, 80 countries if you take the premium car manufacturer. So it's very important that such kind of an infrastructure works in the same way, not only in Germany, but also in South Korea, in Japan, in China, in the US, in South America, and so on. So it's a collaborative action and it's a collaborative effort. We are doing that together with partners worldwide and around the globe. What I have said is a new concept of increasing the position accuracy, which can be derived out of a GNSS a positioning signal by distributing correction models. And you know, maybe some of you are aware about these already well known and very well established in a variety of industries, like in the construction industry. The concepts of differential GNSS, real-time kinematics, and a variety of different other models are very well known. But today, this kind of functionality is more or less a niche functionality for niche use cases in the construction industry, for niche use cases in agriculture, for instance. So we want to leverage these kind of concepts and use cases also for a mass market for the automotive industry. So more or less, we have already we as a mobile network operator have already all the different aspects and the different components of computing and distributing a differential GNSS correction model in our hand. We have already the sites, which is a distributed infrastructure which can be used as as reference station for GNSS. We have, as I said, decentralized cloud infrastructure which is able to compute and to provide computing power high availability computing power, and if we have, of course, our mobile networks, which we can use to distribute the correction model to a variety, maybe also in the broadcasting mode, to a variety of cars. So this is also one functionality we are providing right now here around the Munich area, around the motorway A9. So if you are interested in to use your car or to explore what kind of position accuracy benefits you can create out of such kind of an infrastructure, please give me a call. If we are talking about connectivity in the cars, 100% of the cars are connected. We have to talk about quality of service. Very often we receive, as a network operator, we receive from the car industry that we don't have a bandwidth problem. The bandwidth is already there. Even with LTE, the bandwidth is sufficient, but we have a coverage problem and we have a throughput problem in certain regions and in certain periods of time during the day. So what we have to face from a network operator perspective, we have to organize our networks in a way that the specific requirements of the connected car industry, of the various services of the connected cars, can be realized within a specified and a certain specified network, logical network within our mobile networks. And this is one very important topic within the whole 5G discussion. So this will be a major capability within 5G to organize, to operate, and to offer these kind of network slicing behavior to certain industries, and of course the car manufacturers and the car industry, the mobility industry, transportation industry is a very important topic for that. As I said, we have, around the world are right now conducted a variety of tests and test beds for that. We have invented an infrastructure which works even without the help of a mobile network, and that is the LTE V2V, or with the next standard 5G, this will migrate into the 5G standard. And this kind of infrastructure enables a car to communicate between cars and to communicate with traffic infrastructure. We will use for that kind of communication at the first, let's say in the first global standard, the 5.9 gigahertz, which can a band which can be leveraged here in Europe, in China as well, and also in the US. It's discussed right now heavily to use also this 5.9 gigahertz spectrum for the V2V and V2I communication infrastructure, not only for the old and traditional 11P DSRC standards, but also for the upcoming standard, which is LTE V2V. We have right now some first chipsets available, testing equipment available, commercial availability will be realized by chipset vendors like Qualcomm, Intel, and so on. So they have already made announcement that this will be available in the near future in the market. Finally, it's not an effort of one company. It's not an effort of only a partner network around the globe. It's a global effort where a lot of companies are working together in a variety of organizations, whether it's a 5G PPP, whether it's a NGMN, which is the Association of the Mobile Network Operators. 3GPP is, of course, a very important standardization activity, but also specifically related to the automotive industry, specifically formed alliances like the 5GAA, like the European Automotive Telecom Alliances, where a variety of car manufacturers, first-tier suppliers, chipset manufacturers like Intel, Qualcomm, roadside operators, roadside unit vendors, and of course the telco industry with its suppliers are working very closely together in a collaborative effort, in a joint effort to bring connected cars, and not only the normal functionality everybody is receiving right now in his car, but also a variety of additional functionalities out of the upcoming next generation networks in the future. So 5G is an evolution which drives us from LTE to 5G. 5G is not only about a new radio like it was in the past, so 2G, 3G, 4G. 5G is not only a new radio standard, but it's, and that is much more important for the connected car industry, it's a new concept of organizing networks, of deploying networks, of operating networks, and of operating and providing services together with these networks to best achieve in the best way the requirements of the car manufacturers and the automotive industry. So thanks a lot for your attention. I don't know whether we don't able to answer questions, but I will be outside, so continuously available during the whole day for your questions. Thanks a lot again for your attention.